Hi everyone! So this is the first of 5 videos about stacks and queues. And in this video, we're going to just sort of do a introduction and a run through of the concepts of what is a stack and what is a queue and what are they generally used for. So let's start off with some basics. Now, stacks and queues are both what are called abstract data types. And what that means is that we care about what they do, but we don't typically care about how they are implemented. So remember we talked about this when we talked about lists, right? So with a list, it's an ordered set of values, and how you implement them uh, it could be a linked list, could be an array. There's an effect in terms of the performance, but when we're talking about it in general, you can actually use either to implement a list. Similarly, with a stack, you can implement them using a linked list. You can implement them using an array. Okay, but what we really care about it is the order with which we add and remove items in these two data structures. And they're separate, and they're both useful under different circumstances. So you can't really use a stack where you need to use a queue, and you can't really use a queue where you need to use a stack. So you have to sort of um, think through sort of like what it is your intention is before you choose to use one of these data structures. Neither of these data structures should be used as general purpose storage. So what that means is that if I wanted to take a bunch of data, put it into some data structure, and then be able to access any one piece of the data, this is not the data structure for that, okay? So if you put it into a queue, you put it into a stack, what you really care about is the order with which you add or remove an item. It isn't where that item is or some item that's some other piece of data that's associated with it or something like that. That's not what this data structure is for. So keep that in mind. These data structures are very specific in terms of their purpose. Their purpose is to track order. Okay, so very, very important idea. Now, a stack is first in, last out. We're going to talk a little bit more about that. Typical uses of a stack are for things like, for example, bracket checking uses a stack. Um, that's one of the things that you can use with a stack. And so you're going to see that in Lab 5. Writing recursive functions iteratively is another use of a stack. So when you're writing a recursive function, sometimes there are reasons not to write something recursively. It is better to write it iteratively. And so, so if you want to write a recursive function, but you also saw that, like, for example, when you were doing lab 2, that there were functions that were just so much easier to write recursively than it was to write iteratively. Um, so if you want to write something recursively, but you have to have an iterative solution, what you can do is you can sort of mimic that recursive call by using a stack data structure as opposed to using the runtime stack, as opposed to using recursion itself. So there's actually good uses for stack for those kind of purposes. Queues are also useful. So we're going to see this later in the term when we start talking about trees. So queues are used to do what are called breadth first traversals. And we'll talk about that when we get to that for trees and also for graphs. But I don't know if we'll have enough time for talk about breadth first traversal of a graph. But in any case, we'll talk about what queues are used for later in the term. And as I said, there are implementations in both linked lists and array forms. Now, before we get to the implementation, though, let's make sure that we understand what a stack and a queue can do. So when we talk about stacks and queues, what we care about is really taking data, putting it in, taking some data out, accessing a very specific piece of data, and possibly checking whether or not the stack or the queue is empty. So typical operations are push and queue. These are different names for doing the same thing, which is to add a value to the stack or in the case of NQ, a queue. So push is the term for pushing data into a stack, and queue is the term for pushing data into a queue. Now, oftentimes people just use push these days, whether they talk about stacks or queues, but we'll use this terminology. It's also the terminology that's in the notes. We also have pop and DQ. Pop and DQ are basically talking about the same thing. It basically removes a value from stack queue. Now, this is a specific value. Okay, so this isn't just removing any old value from the stack or the queue, it's actually removing a very specific value. Now, remember that in the case of a stack, it is first in, last out. Okay, so for stack, newest item removed is removed. Whatever you just added, that's the one you get that gets removed. And for a queue, oldest item is removed. And we'll talk about this sort of more pictorially in a moment. We also have a top and front function. This returns the newest item in stack or the oldest item in queue without removing it. So basically think of what the thing you would pop is. This is accessing the thing that you would pop or the thing that you would DQ. That's what this function does. Now, so the stack functions are push, pop, top, and the queue functions are NQ, DQ, and front. But if you think of it as putting something in, taking something out, and accessing the thing that you care about, that's really what those three functions do. Might have different names, but that's what they do. Okay. There may be a function that checks whether or not the stack or the queue is empty, but these are the three that are the most important of all. Okay. So now, before we move on to implementation, let's take a quick look at how a stack and a queue would work. So let's say that I have the following values, 1, 5, 9, and 10. So with a stack, what I would do is I would, so this is a picture of a stack. So remember that stacks, we talked about this when we talked about the runtime stack. Stacks are like a tray, like cafeteria trays. So when you put something in, you put it on a tray and you put it at the bottom of the stack. And then when you put another thing on, you put another tray on top of that. So when we put the one in, so imagine that we're going to insert these values, push these values one at a time. So push 1, push 5, push 9, push 10. Okay? So when we push front, when we push 1, not push front, push 1, sorry. Push the number 1 into the stack, it ends up at the bottom. Now, right now, at this moment, this is called the top of the stack because this is the value that's at the very top, right? So if we put another value in, we simply add it to the top of the stack on top of it, and now the number 5 is the top of the stack. Then when we push in the number 9, it gets added, and 9 is now at the top of the stack. Okay. And finally, when we add the number 10, the 10 is now at the top of the stack, and so on. Okay, so this is how push works. Now, what would happen if we were to do a pop? Okay, so what does pop do? So imagine that I call the pop function twice. Okay, pop and then pop again. What would happen? Well, pop simply removes the most recently added item. So if I were to remove the most recently added item, then the 9 becomes the top of the stack. And if I were to do another pop, then the 5 becomes the value at the top of the stack. And what you will see is, and this is how it basically works. Now, top is simply returning whatever value is at the top of the stack at that moment. So this number will change as we put things in and as we take things out. Okay, So this is effectively how the stack works. So conceptually how this works, okay? Now, if we think about this for a queue, what would be different? So if I took the same set of values, 1, 5, 9, 10, and I thought about this in terms of a queue, what would happen? Well, a queue is a fancy way of saying lineup, okay? So the way that you can picture this is that there's a line, okay? And this is the front of the line, okay? So when I take the number 1 and I put it in, it's at the front of the line, okay? So this is the front of the line, okay? Now, when I take the number 5 and I add it, the 5 is at, it gets put into the back of the line. Now, we don't actually care about the back of the line in terms of like where it is. We just have to know where to put the next item. So 5 is added to the back of the lineup. Then we add the number 9. 9 is added to the back. And 10 is added after that. Now, remember, so in the case of the push, in the case of, sorry, the stack, we remove the most recently added item. So if we were taking items out, we would take out the 10 first or the 9. When it comes to a queue, we care about the oldest item that is in the queue. So for example, here, the oldest item, the first thing that we added was the number 1. So if we were to do a DQ, which remember is just the queue way of talking about pop, if we did 2 DQs, what would happen after the first one is the number 1 would basically be gone. Now, how we deal with who's considered at the front and so on depends on the implementation, but effectively, the newest item, or sorry, the oldest item in the queue after I remove the 1 is the 5. The front is also now, this 5 is now considered the front item in the queue, okay? So this is the new front, if you will, okay? Now, how exactly we implement this, we'll talk about this later, but this is now the front of the line. If we were to DQ again, okay, then the 9 is at the front of the line as opposed to the 5. Okay, so this is the new front. Okay. And so now what we were removing were the 2 oldest items. The 9 is now considered to be at the front. Okay, so this is how things work in a queue. So imagine that this is like a supermarket lineup. So person 1 entered, then person 5 entered, then person 9 entered, and so on. Uh, and that's pretty much it. Now, I just realized that these numbers are sorted. They don't have to be sorted, okay? The sortedness has nothing to do with it. The first number could have very well been an 11. It just happened to be a 1. But so sorting has nothing to do with ordering. It's simply just because I just wrote down a bunch of random numbers that they happen to be sorted. That's all it is. So in any case, hopefully that sort of explains what they do, what a stack is, what a queue is. The much more interesting part of this is how do we actually implement a stack or a queue. Those are going to be in the next 4 videos. We're going to divide it into in the following way. We're going to talk about stacks. How do you implement a stack using a linked list? How do you implement a stack using an array? How do you do it with a queue with a linked list? And how do you implement a queue using an array? Okay, so that's it for this video. I'll see you in the next video.